Today we will be focusing on Module 13C, and it's to use retrosynthesis to prepare a trisubstituted benzene from a benzene. In order to do this, we have to perform a retrosynthesis based on order of reactions. The key concepts include understanding what electron donating and electron withdrawing groups are, understanding what makes a substituent group an activator or deactivator, knowing what position of a benzene ring a substituent will be present on, and understanding how to go from a trisubstituted benzene to a benzene using retrosynthesis. Now, to understand this concept, we must understand what retrosynthesis is. Retro is backwards, and synthesis is the process of combining simpler reactions to form a chemical compound or molecule. So, presented in the form of a complex molecule that you are asked to synthesize from a given starting material or a set of reaction conditions. In this case, you are presented with the product, and you have to get that product from the... Now, in order to do this, we see the product, and first we have to analyze the groups on the rings and their positions. So we see that there's a methyl group present over here, we see that there's a nitro group present over here, and we see that there's an acyl group present over here on the ring. So the methyl group is an activator because it's an electron donating group, and it adds on to the benzene ring in the ortho and para positions. The nitro group and the acyl group are deactivators because they are electron withdrawing groups, and they add on to the meta positions on the benzene ring. So now, to understand what exactly all of those things mean, we have to have some background knowledge on all the key concepts. So, ortho, meta, and para are prefixes used to indicate the positions of non-hydrogen substituents on a benzene derivative. So this is the benzene derivative, and it has an R group present on it. In terms of the R group, this is the ortho position. It's the 1, 2. The meta position is the 1, 3, and the para position is the 1, 4. These positions are determined by these substituents. So in this case, we have a benzene ring with a methoxy group attached to one of the carbons. A methoxy group is an electron donating group because it has lone pairs on an atom connected directly to the benzene ring. The atom connected directly to the benzene ring is the oxygen, and it has two sets of lone pairs, which makes it an electron donating group. This also makes it an activator, and it adds on to the ortho and para positions. This is because when drawing the secondary resonance structures, you can see from this resonance hybrid structure that there are partial negative positions present on the ortho and on the para, and those partial negatives on the carbons would act as better nucleophiles than the neutral charges present on these two carbons in the meta. That is why it adds on ortho and para. In terms of electron withdrawing groups, we have a carboxyl group present on the benzene ring, and this is an electron withdrawing group because it does not have lone pairs on the atom connected directly to the benzene ring, which is this carbon over here. This also means that it is a deactivator, and it adds on the meta positions. So we also can look at the resonance hybrid structure of this, and we could see that there are partial positive charges on the ortho and on the para position. And because we see that there are partial positive charges and no partial negative charges, although there are no partial negative charges on the benzene ring, the neutral charges that we see over here on the meta positions are actually better nucleophiles than the partial positive carbons present on the ortho and on the para, which is why in these reactions, it will add on to the meta position. So now that we have more understanding of what all of these mean, we can look back at the product, and now we can figure out a way to get to this product from the benzene ring using retrosynthesis. Now, the question here that we first have to ask ourselves is, what is the immediate precursor to this molecule? So what reaction occurred right before we received this product? So we look at what we have present over here, and this nitro group is ortho to. So now that we understand all of that, we could look at our product, and the first question we should ask ourselves is, what is the immediate precursor to this molecule? And in order to understand what the immediate precursor to this molecule is, we have to understand what these groups mean. So this methyl group is an activator because it is electron donating, and the nitro group over here is an electron withdrawing group, and it is a deactivator, and it is in the ortho position in relation to the methyl group. The acyl group is also a deactivator because it is electron withdrawing, and it is in the para position to the methyl group. And in terms of the acyl group and the nitro group, the nitro group is meta to the acyl group. Now that we know that, we have to think of what the Friedel-Crafts acylation can do. And in terms of that, it will not add on to the benzene ring if there is an electron withdrawing group present. So we know that the precursor to this has to include the acyl group and not the nitro group. So now that we look at what is seen next, we see that this is the immediate precursor, and in order to attach the nitro group, we must go through this reaction, which is nitration, and it uses nitric acid and sulfuric acid as the acid catalyst. And when those reagents are added to the mixture, you will receive this product. Now, looking at the next step that we have to see, what is the immediate precursor to this molecule? Now that we have the acyl group and only the methyl group, we know that the acyl group occurs from Friedel-Crafts acylation, and it will only add on if there is no electron withdrawing group present. And that's good in this case because the methyl is electron donating and is not electron withdrawing. So we can recognize that the immediate precursor will look like this, and it will be a toluene, and it'll just have the methyl group connected to one of the carbons. And in order to go from this molecule to this immediate precursor, we have to do Friedel-Crafts acylation, which includes using acyl chloride and aluminum chloride in order to get the acyl group para to the methyl position. Now, it won't add to the ortho positions because of sterics. It would be sterically hindered if it adds onto these because there will be too many carbons present close to each other. So now after looking at that, we can see that our final step is having the benzene ring. And in order to get this benzene ring, go from here to the toluene, we must use Friedel-Crafts alkylation because it could add the methyl group by using the chloromethane reagent and also the aluminum chloride. So that's how you get from the product to the benzene ring using retrosynthesis. Now, as you can see, looking through the reaction as a whole, when doing Friedel-Crafts alkylation, you could add the methyl group to any carbon of the benzene ring. From there, when doing Friedel-Crafts acylation, this reaction will go through because there is no electron withdrawing group present. There is a methyl group present, which is electron donating. So in this case, because it is electron donating, it will act as an activator, and it will place the acyl group onto the para position because the ortho positions over here will be sterically hindered And so the carbons over here will not want to be present next to the carbon over here. So in this case, because it adds on para, you have this molecule over here. And now in order to add the nitro group, you must go through the process of nitration, which includes the nitric acid and the sulfuric acid being used as the acid catalyst. These reagents will put the nitro group onto the ortho position of the methyl group, because since this is an activator, it will either want to put it on the ortho position or the para position. And in this case, we cannot put it on the para position because there's already a substituent present on it. And when looking at the acyl group, it's a deactivator. So in this case, it would want to put the substituent into the meta position, and that can be either over here or over here. And since it would be the same molecule, whether it be here or here, you could put it onto this carbon over here, and that's how you will receive the overall product from a benzene ring using